Hello from Gdańsk, Tomasz Pawłowski here. I'm a Squish technical consultant with FrogLogic. I would like to present today how to create automated GUI tests for embedded applications. Currently, graphical user interfaces expose a lot of application functionality. As developers and testers, we need to make sure that the user interface actually looks and behaves as intended. In this talk, I will present a proven approach to creating fully automated and robust GUI tests for Qt application running on embedded devices. I will use an ARM IMX6-based device running a Qt-based GUI. Squish is deployed to a device. It takes a little bit over 120 megabytes there. I will demonstrate how Squish GUI tester tool can be used to develop automated GUI tests. At the beginning, I will show you just a few slides. Later, I will create a few automated test cases. Finally, I will demonstrate how the novel remote control feature works. So what in fact is the Squish GUI tester? It's a cross-platform multi-technology tool for GUI test automation. Squish supports testing on Windows, OS X, various Linux distributions, and other operating systems, including mobile, Android, and iOS. Squish can be cross-compiled to other platforms like Linux running on ARM devices. Moreover, tests created with Squish are fully portable among different platforms and configurations. Squish features dedicated support for GUI test automation of all Qt widgets, QML, and Qt quick controls. You can even automate interactions with embedded web content if it's implemented using Qt WebKit or Qt Web Engine. We support testing Qt Toolkit up to recently released Qt 6. We provide support for new Qt versions as soon as they are released. With Squish, we have access to all object properties, methods, and signals emitted by widgets. Let me tell you a few words about Squish architecture. The heart of Squish are two processes, Squish Runner and Squish Server. Squish Runner is responsible for triggering test execution, interpreting test scripts, and generating results. Squish Server is responsible for starting and handling application under test. During execution, Squish Runner is connecting to Squish Server. They communicate over TCP/IP protocol. Therefore, it is possible to run your test in a distributed manner. In an alternative setup, Squish Server is even not running on the device. The application on the device is started with Squish tool called Start IoT, and tests are attached to already running application. In another alternative setup, application under test is modified to use so-called built-in hook. Tests in Squish can be fully recorded or manually scripted. You can record the whole test case or just part of it to extend an existing test case. Manual scripting is for more advanced users who know Squish API well. The most popular approach is a hybrid approach, where users record their code snippet, refactor it, and put it into the right place of designed test framework.
Let's take a look at cross-platform Eclipse-based Squish IDE. You can use IDE to develop, maintain, debug your automated tests, or just to spy the UI components of your application under test. First, let me show you my configuration. If I go to Edit, Server Settings, Manage IoTs, Attachable IoTs, you can spot an entry named Greenbox with the IP address and the port number. And this is in fact where my application is running, and this is the device which is connected to the network. First, we need to create a new test suite. We can give it any name. We click Next, and then we need to tell Squish what toolkit we are using. It's a Qt application, so it's a Qt toolkit. And with Squish, tests can be recorded or scripted in Python, JavaScript, Perl, Ruby, and Tcl. All those scripting languages are supported equally, so it's up to your team preferences which one to choose. We'll go with Python, and we click Finish. Let me now create a new test case, and we can make our first test case will be a recorded one. So I click a record button, I choose my application to Greenbox, and I click OK button. Now Squish ID is minimized and you can see the video camera pointing to my device, and I will just record some actions. I will click on buttons, go to different tabs and then turn off this button, and I will click stop recording. You could see that the test case was recorded, which means that Squish generated a Python script. If you look closely at this Python script, you can see that at the beginning we attached to the application, and then you could see some Squish API commands like click tab, wait for object, etc. This script is very short. You can just click a play button to replay that, and you should quickly be able to see that the test case replayed successfully, and it just took 3 seconds to repeat all those interactions we did with the application.
How Squish works? How is this possible? Squish hooks into the application and recognizes application GUI elements as objects. With Squish, you can interact with properties and methods of those objects. It's important and powerful that Squish is not relying on screen resolution, screenshots, or coordinates. When a button you click in your test script changes its look or location or size, your test script will continue working without any problems.
Let's create the second test case. This time we'd like to verify that the application is working as expected. So the record button again, and if you go to the buttons tab, we'll click this switch button. We'd like to verify that this light is on, and to do this we'll use the verification points, and with Squish you can verify object properties, for example text property. You can do screenshot comparison. You can also do visual verification of content, geometry and topology, visual appearance, and the newest additions to Squish verification capabilities are search image verification, OCR text verification. I would like to verify the property of my LED object, and now I need to select the object which I would like to verify. So I can just use the picker tool, tap this object, and on the bottom right I see all the object properties. I can verify any of them. I will go with the glows property with current values true, save and reset verification. I'm done with my test case, so I can click stop recording. Let's take a look quickly at my application. You can see currently the light is on. As I'm attaching to the application, so this time when I run the test case, I expect it to fail because after switching the light, switching the button in the line 9, it will be off. So in line 10, we will have a failed verification. Let's see that. And you can see that the verification failed. If you look at the results, Squish took a desktop screenshot, so you can see the actual look of the application display at the time of the failure. If you run the test case again, you could see now the light is off. So if we run the test case again, this time your test case will pass. And of course, user can implement its own logic to only click on the button when the light is currently off. In the third test case, we will verify that our speed gauge looks as expected. And to do this, we'll use screenshot verification point. Let's create a new test case, hit the record button. I'm recording. Now I will set a speed to value 50 kilometers per hour. And now I will verify the look of this speed gauge. So I choose screenshot verification point. Let me pick my speed gauge object. You can see it was picked here. And to make a screenshot comparison, I just click a checkbox next to the object name. And you can see that this screenshot, the actual look of this UI control was taken. After saving that, we are back to the recording, but we are done. So the test case is very short. We just set a speed to 47 kilometers per hour, and we call test VP VP1, and our expected verification point, our expected look of the speed gauge is saved here. When you run the test case at the first time, you can see that the result is pass, and Squish is saying that screenshots are considered identical, so both actual and expected one. If in the test script we will change a speed to 37 kilometers per hour, and then we rerun the same test case without changing the expected image, this time Squish is reporting a failure, that screenshot do not match. We can always analyze what is the difference between actual and expected image, and we can look at the images in a different ways. We can use a flickering between expected actual, subtract them, do some red and green deep, so just plenty of options. If we actually are saying that our image in fact is correct, we want to update the test case, we can just click use as expected results, and then the new expected image is created based on the actual image from the last execution, and I run the test case again, and this time the test case should pass.
Conceptually, visual verification is a hybrid form of property verifications and screenshot verifications. Both types of checks are now combined into a single complex algorithm to find the best possible match. Unlike screenshot verifications, they do not just treat the rendered screen content as a single surface. Instead, the area is divided and compared per individual UI control. Rendered pixels, positions, size, and content properties will be compared against expected values. When to use visual verification? To check the on-screen display of dialog, whole application windows, or subsections. By default, all checks will be performed in a strict manner that does not allow for changes in state, layout, and rendering. User can relax those checks later.
In the next test case, let's perform a visual verification of all meters located on this QGroup box. When recording a test case, we will set a speed to some value, heating to some value, and verify all the controls located on this QGroup box at once using visual verification. Now we need to pick our QGroup box for the verification and click the checkbox next to the object name, and now Squish fetched all the information about all the controls located on this QGroup box, including the contents of some properties, geometry, including location of objects and their sizes, and screenshot for each control separately. I'm done with this test case, so let me stop recording. In the last line, you see that we called our visual verification point. Let's replay the test case. The result is pass. If we modify the data we use in the test case, so change the speed to smaller value. Let's run the test case without changing the expected results. You already see there is some difference here in the look, and we have information that visual comparison of this object electric car QGroup box failed. If we go with the view differences, we have visual VP differences, and we can analyze what objects failed visually in our test case. And if you look at the each object on the right, we see that this object failed on the content check, so property geometry was fine, topology was fine, and the screenshot was different. Yes, and we can analyze all the objects located in a QGroup box to see what was the difference, why there is a failure. We have plenty of options to choose here. We can relax checks, we can accept new values, etc.
In those cases for which object-based recognition is not suitable, the Squish GUI testers offers an image-based recognition approach. Image-based testing is best used for application with custom controls application built with unsupported toolkits for which object properties are not available. We can use image-based testing to test 2D, 3D graphics or plots, such as medical imaging data. With image-based recognition, UI control is recognized by its appearance. With Squish, user can define a scenario to verify the image presence or to perform an action on an image, for example, click or double-click the image.
And now, using image-based testing, we'll verify that this nice wave is present on this graph. In the Squish, create new test case, hit record button, and now verify option, search image. Squish took the screenshot of the entire desktop. We'll just select the area with our wave. You can change the search region just to search the main window of our application. At the bottom right, you can set the file name to wave, click insert verification and click stop recording. Now the test case is created, and in this test suite resources, in the search images, here is our expected image. And we can replay the test case, and shortly we can see the result. There is a pass message with the information the image wave occurrence 1 was found. Image-based testing can be also used to interact with a found image. So let's record a new test case. And by default, all the interaction with the control is recorded using object-based approach. So I will click on the buttons. And now if I would like to click on the image of this switch button, I need to choose an option from the control bar, insert a mouse click image. And because we already have some search images in our test suite, we can first reuse the already taken images, or we can make a new image. I will choose to make a new image. Now I will select the image of my switch button. I will again choose a search region to just my main window and give it a name, button, and I can click insert, and I'm done with my recording, so I click stop recording. And now you can see that in the last line of our test case we call mouse click command, and this time the mouse click is not performed on the object reference but on the screen area, which is returned by the wait for image function. So we just look for the area on the screen where the button image is located. And if you look at the test suite resources, search images, now we have two images here, the button that we use for the interaction and the wave PNG that we use for verification in the previous test case.
What to do if target device is not in the same physical location? How to record a test case on such device or pick up an object using the picker tool. There is a solution for that common challenges in remote device testing. Squish 6.6 offers a remote control features. So when working with a remote application under test, Squish allows you to stream the display of the remote device locally on your machine in real time. When interactively recording tests, you can, from within the remote viewer, actually pick UI objects for inspection. You can use the Squish Spy tool for setting up a verification point. You can preview the current AUT states in a debug session and more. Let's see this feature in action.
And the last test case will be created without accessing the real device. I will just use Squish IDE. I am starting the recording as before, but this time I will click the remote control option here, and I will interact with my application using the preview window displayed as a part of the Squish IDE. So I'll go to buttons and I will click my switch button. And now I will add a verification, let's say property verification. As usual, I need to select the object I would like to verify. I'll use the picker tool, but this time I'll pick my object from the preview displayed in the Squish IDE. I'll look for the property and will select that the property is false, and I'll click Save and Insert Verification. I'm done with my test case. I can click Stop Recording. As you can see, the test case was created in the same way like before, but this time I haven't interacted with the device at all. All my actions were performed on the preview of my application, and this preview of course is a part of the remote control feature.